Hello. So this is going to be a demonstration on how to use Minitab, which is a statistical software, to design experiments and also to study the regression. So, for example, if you have an experiment such as this one, where you have three factors and each of those factors have, say, three levels as seen here, we can go with a variety of designs for your experiment, and we will be going with the full factorial design. So how you go about it is you need to go to stat DOE, go to factorial, and create a factorial design. So here you have the different types of designs you can employ, but we will be choosing a general full factorial design. And as I showed you, we have three levels, factors. So select three. Now select designs. Here you can name your factors. So you have mole ratio, catalyst loading, and time. Now as I showed you, each of these have three levels. And make sure the number of replicates is set to 1 and hit OK. Now go into the factors, and here you will see that you have to specify the level values. So for mole ratio, my level values were 3, 5 and 8, which I will specify. Similarly, I will specify the remaining level values as well. There we go. Now we will look at the results, and if you want a design table as well, you can select that. You can go to options and make sure your runs are not randomized if you want it in order, otherwise you can keep the box checked. Now that everything is specified, we can hit OK. Now as you can see, we have a total of 27 base runs, right, with three factors and three levels. So here you have 27 experiments, and here you have the conditions. So now if I take a look at the first one, I have a mole ratio of 3, catalyst loading 0.5 at a time of 1 hour. So this is your first experiment. Now what parameter will this have a response on? That will be the yield of your reaction. So as you finish your experiments, you will be tabulating the values in these cells. So with me, I have the experimental values, which I will show you. So once you're done with all your experiments, you will have all these values here. And now we can condense all of this information into one regression equation, which will predict the response of your experiment. So to do that, go into stat regression and best fit, the fit the regression model. So what are your responses? Your response here will be yield. And what are your continuous predictors? Mole ratio, catalyst loading, time. Now it's highly probable that you will want to understand the cross interactions as well. So here you only have three terms: mole ratio, catalyst loading, time. Say you want to study mole ratio, right? So here you have mole ratio, select this term and hit add. So you have mole ratio. Next I want to study mole ratio, catalyst loading. I will add that as well. Mole ratio and time. I will add that here. Similarly, catalyst loading. So yeah, because I have three factors, if you consider all the interactions, you will have 9 terms in the model as seen here. So click click OK. Make sure you have included the constant term, and you can hit OK. Now, here in the worksheet, you can see the regression analysis on yield, which is your response variable, versus your factors. So here, this right over here is your regression equation, and you can see the p-values that have been generated and model summaries, important information like R-square, and your ANOVA table over here with p and f values. So now if I want to visualize this in terms of graphs, I can go back to stat, I can go back to regression, and here I have two options of either visualizing it as a surface plot or a contour plot. So if you go to surface plot, you can set the axis here. See, the response we're studying is yield, so you can set the x-axis as any of your factors, and you will have a surface plot. In a similar way, we will generate a contour plot. This way we can study all the factors in their effect on the yield individually. Thank you.